Hello and welcome to our chapter on fractions. I encourage you to read through the manual carefully as well, since I won't be doing everything in as much detail as a book can explain. So definitely look at that in addition to this. The first thing we want to do is talk about how we understand fractions from an elementary teaching point of view up to our own understanding and use of fractions. So what I like to look at is what I call the understanding spectrum, as cheesy as it is. And on the one side, I have an intuitive understanding of things, concepts, and in this case, we're mainly focusing on fractions, of course. And the intuitive side is where I don't have any fancy formulas. I don't have any large numbers, complex calculations. The numbers are kept simple to have an intuitive feel, a number sense developing. And for the large portion of the elementary teaching, we try and stay on this side as much as possible to create that number sense in students. But and we are going to focus on this side as well, uh, hinting at what the limitations are, because the problem comes in when the numbers get big. They're clumsy, they're difficult to work with. I can't do the arithmetic in my head as conveniently. I want to be able to slowly drift away from this intuitive side to a deeper mathematical understanding of how do these concepts actually work and relate to each other. This is where we develop formulas to be more efficient and to handle larger, more complicated situations. I can't really be without either side of this. I can't just be using formulas without any understanding of what I'm doing, because I won't be flexible to actually solve problems and develop my thinking and understanding. And I also can't stay fixed on this intuitive side, because I won't be able to adapt to more complicated situations, whether the numbers get larger or the situation is just more complicated, the problem. So I want to keep this in mind and develop the ability to move back and forth as I need to, and as the audience that I'm teaching one day perhaps needs to. So when we talk about a fraction, we talk about a quantity. Let's suppose I have a loaf of bread. I'm gonna draw actually I have a rectangle tool. What am I doing? I have, whoa, that's too big. I'm just gonna center this a little better. Clearly I'm having some technical problems, but not for long. I have a loaf of bread. There's my loaf of bread, a very rectangular loaf. And perhaps I need to split that up, let's say into 5 pieces. Now my pieces won't be perfectly equal, but I'm cutting it into 5 pieces. And historically, this was a problem, that they have a loaf of bread, they have to split it among many people. But before fractions, they didn't have a representation for this quantity. We have one loaf of bread, yet we are focusing on maybe just this portion. So someone can get one of these slices and say, I got this much bread, but I don't have a number for that because it's not 0. It's not one loaf of bread. It's in between. So they created fractions to represent these in-between quantities. Now a total, you could say then, I got 1 loaf of bread out of 5 that would make the whole loaf. And the concept of a fraction was born. This is how much I have. Let's say here, have. This is what I have. 1 piece out of the total making up 1 whole. So now there's a difference between the 1 I get and the 1 whole. And there are many other fractions depending on how many pieces I divide the loaf into. And we have this diagram to represent this quantity. You can use a circle, thinking of pizza slices, but I'm struggling to get my pizza slices all the same size, so I'm going to stick with a rectangle and thinking of the loaf of bread instead. But you're free to do whatever diagram you feel comfortable with. My drawing skills are limited, as we saw, so I'm going to stick to a diagram. So I'm just going to check, because I don't want to miss any exercises, if there are any we need to do. Our first exercise, 14.1, is represent the following quantities with rectangles. I'm going to stick to rectangles, though you're free to change that to other things in your teaching one day. I'll zoom in a little bit. That's nice. So exercise 14.1, 1/3. Oopsie. Exercise 14.1. And the quantity that I want to do is 1/3. So now it's too close to my third. Why am I struggling with this so much? Now I am taking my loaf of bread and splitting it into 3 equal pieces and giving 1 of the 3 slices, or having 1 of the 3 slices, and there is my answer. So it's a very intuitive understanding of a fraction. I have, if I count loaves of bread as 1, 2, 3 loaves of bread, I can have quantities in between by slicing that up into smaller pieces. And that is the concept that that is the quantity that a fraction represents. Let's look at the second one. 3/4. 3/4. Let me make my loaf of bread. I think this draws from the center out. Yes, so let's adapt that. So there we go. So now I'm going to split this into, that can be done better, 4 equal pieces. Mine won't always look equal, but I try my best. It's pretty close. And I want 3 of them. So I can highlight 3 of the 4 slices. That represents my quantity. So very intuitive, visual representations are often on the intuitive side. 2. I maybe don't think of 2 as a fraction, but think about what the fraction meant. I'm splitting my 1 into this many pieces, and I'm taking a certain number of those pieces. I can say 2 is 2 over 1, meaning I don't split up my loaf of bread at all. Rather, I have 2 of them. 2 loaves of bread. Not splitting them up at all. Splitting them up into 1 piece, therefore I have the whole loaf of bread, and I have 2 of them. So I have 1 loaf of bread, 2 loaves of bread, and in that sense, the fractions really extend the integer concept. That integers are now included as fractions by looking at that number over 1. let me just say here, this is called the top one is called the numerator, and the bottom one is called the denominator, just in case you need a reminder of those names. So I can write an integer with a numerator and a denominator as well. Let's check, is that everything we need to do? There's no number 4, all right. Now, the next question is, I can have different types of fractions. Slightly different, not really. As you see here, I can have multiple loaves of bread. So if, for example, I have 2 loaves of bread, my loaves will never be the same size exactly, and I split them up into halves. And I give someone 1 whole loaf of bread and half of another one. I can say here, well, this is 1 loaf of bread, and here I'm getting a half of another one. That I'm, of course, adding together, and I can represent that as 1 and a half. Very intuitive. Very intuitive. We'll call this a mixed number or mixed fraction. Something that has a whole portion and a fraction portion to represent the quantity. Very intuitive, and a mixed number should certainly stay on the intuitive side. When things get complicated, the mixed number turns out to be a little inefficient in my calculations because I need to remember that these two seemingly separate numbers actually go together representing one quantity. So I have types of fractions called mixed numbers. If I just had, so just this on its own is an integer, and just this on its own is what we call a proper fraction. An actual smaller part between 0 and 1 whole loaf of bread. For calculation purposes, we can also look at this whole thing and represent it in a different way, saying, well, I'm cutting a loaf of bread into 2 pieces, and I have 3 of them. I have 3 halves shaded there. This is the same quantity, and we're calling that an improper fraction. Improper when the numerator is bigger than the denominator. Proper when the numerator is smaller than the denominator. Mixed when there's an integer and a fraction portion. And in the mixed number, this fraction portion will always be a proper fraction. Again, the textbook, as you can see here, has definitions and all kinds of things that I encourage you to read up on. So in 14.2 exercise, we want to represent the following quantities with rectangles as well. Now we see some mixed numbers. For some reason I have a 2 in both, so we'll skip that one. We've already done that. 2 and, let me just write down the number here. Exercise 14.2, number 1. Now let's see, what was it? 2 and 1/5. 2 and 1/5. When I see this, I should certainly think of 2 plus another 1/5 of a loaf of bread. So I have 1 loaf of bread, 2 loaves of bread, which will never be the same size, but they are identical, remember, and another loaf of bread. They are identical and counted as 1. So I'm splitting this up into fifths, but I'm taking the whole first loaf, I'm taking the whole second loaf, and this last one is split up into 5. That was not even a straight line down. 5 somewhat equal pieces. Equal as best you can. That was an extremely poor showing. I'll try and be better next time. And 1 over there. And there is my 1/5. Sorry, 1/5 there, plus another 2 for 2 and 1/5. This is bothering me. I should erase this. Let me just pick my eraser here, clean that up. That's much nicer. All right. Number 2. 1 3/4. 1 3/4. Or 3/4. Whoops, that was supposed to be a rectangle. Where's my rectangle tool? There we go. 1. Another 1. I'm taking all of this first one, but only a portion, only a fraction of the other one. Split that into 4 equal pieces according to the denominator and take 3 of them. And there you go. Still intuitive with graphical representations. I'm not going to do that one because it's exactly the same as that one. Not sure why it's there. Now I want to practice converting between mixed fractions, mixed numbers, and improper fractions. So let's think about, let's use the first example to figure it out, and then we'll practice the other 2. Is that over here? Not yet. I'm going to have to make a new page. Let's do it over there. So let's use the first one. What was it? Exercise 14.3, 1 2/3. Exercise 14.3, 1 2/3. Let's use a diagram because we're on the intuitive side. Let's use a diagram to try and make sense of this. Number sense is very important. And in this case, I'm going to split everything in 3 equal pieces, even though I am taking the whole first loaf of bread. When I want to switch it to an improper fraction, I'll have to do this, cut all the pieces, cut all the loaves of bread, but still give myself 1 whole one and then 2 more. So I am splitting it up, splitting a loaf of bread into 3 pieces, and I'm taking, and I have, how many of those pieces? 5, and there's my improper fraction. Now, how do I use this 1 and this 2 and this 3 to get to that 5? Well, notice that 1 whole loaf of bread consists of 3 pieces. So I take the whole portion of the mixed fraction, multiply it by 3 because I have 1 group of 3 slices, and then another 2 slices. Let's do number 2 and see if that works. You can always draw it to help yourself. 2 1/4. 2 1/4. Let's try and visualize this one. Pause and draw it if you want to. I'm visualizing the slices and the loaves of bread there. I have 2 loaves of bread and 1/4 of another one. So I'm cutting a loaf of bread into 4 pieces, 2 groups of 4 plus another 1. 2 loaves have all 4 pieces that I get, and then the last one I only get 1. So that is going to be 9 over 4. So as we work with larger numbers, we may get slightly larger and larger quantities, and it's more difficult to draw it. We're shifting over to that mathematical understanding to be able to handle those quantities. So in general, if I have a fraction that has a whole portion and a little fraction portion like that, I've cut my loaf of bread into C pieces, the denominator. A loaves have all of those pieces, and the last one has B slices. And there's a formula that I can use and develop because I have established my understanding intuitively already. Using the formula, I do know why the formula is what it is, and I'm then safe to use it. If I run through the formula without understanding, that is a dangerous game. How could I go backwards? Let's suppose I have not number 3. Let's suppose I have 9 over 4. Actually, do I have 2 examples there? I do. So I will use that one and then establish how to do it and use it for number 4. So 3 is 15 over 4. 3 is 15 over 4. Well, let's think. Let's draw it out. It's our first one to convert from an improper fraction to a mixed number. 15 over 4. I'm going to need to have, that's going to be 4 slices. That's going to be another 4 slices, 8 slices so far. That's going to be another 4 slices, so 12 slices so far. That's going to be another 4 slices, so 16 would be enough to give myself 15. So I'm going to have to do it. Tedious as it may be, that is how our intuitive understanding side works with diagrams. Really, I just like to draw rectangles and fractions. Never gets old. And the more I do it, the better I get at it. Let's almost be done here. So what do I have? I have 1, 2, 3, 4, 5. I'm very hungry. I get many slices of bread. 9, 10, 11, 12, 13, 14, 15. Not that last one. So intuitively, I have 3 whole loaves of bread and 3/4 of the last one. Now, how do we do this? How do we get the 15 and the 4? Well, if I divide 15 by 4, 4 goes into 15 3 times. 3 times 4 is 12. Take it away, I have 3 left. So my remainder is 3. Now, it's a little unfortunate that they're both 3, but stay with me here. The quotient is the whole portion. The remainder is the new numerator of the fraction portion. Let's try that out on the last one, number 4, which is, oopsie, what am I doing? 7 over 3. 7 over 3. Now you can visualize the rectangles, the loaves of bread. It's totally fine. If I divide 7 by 3, 3 goes into 7 twice. 2 times 3 is 6. Take it away, I have a remainder of 1. So that means it's 2 whole loaves of bread and 1/3 of a loaf left. The quotient is the whole portion. The remainder is the numerator. All right, we're making progress. through our concepts that we just need to establish. The book has a little description there. You can look at it to establish a formula, but that's not that important at this stage. Next up is comparing two fractions, and my exercises will relate to those. I can't get to my page. Why can I not get to my page? Where is my mouse? I have to be able to make a new page. I cannot see my mouse. Where is it? This has happened before. Oh, there you are, you sneaker. Can't get out of this to make a new one. I'm gonna have to do it this way. Ooh, it's gonna be messy. Oh, there we go now. Now I have a new page. Where am I? Over here. I want to do that. All right, we're back in business. I apologize for that. I am obviously somewhat incompetent. So I want to briefly discuss comparing two fractions. Now I have probably another example in the book. I don't want to just repeat what the book says. The book has some little variations that you can look at. So let's suppose I have, oh, that's not what I want to do at all. Let's suppose I have a loaf of bread and I cut it into, let's say, thirds, 3 slices. And I may be interested in 2/3 of that bread. There it is. Now I'm comparing that to a loaf of bread that I cut into, let's say, 5 slices. I keep twisting that line a little bit. 5 slices, they are always equal, even though our diagram might not be perfect. You should always think of them as equal. And let's suppose I have, let's say 3. So that'll be 3/5. I want to compare them and say, is this greater? Is this one greater? Or are they equal? Which one is it? Now, in general, this is a difficult question on the purely intuitive side because I can't, my diagrams aren't that accurate. If I line them up, I can say, okay, well, how long is this? Is this a little longer or not? I don't know, and I definitely can't trust my diagrams that much. And in a way, it's like comparing apples and oranges. If the number of slices of a loaf of bread is not the same, these pieces are different, and it's really hard to compare them. However, if I say, okay, let's just keep these slices together. Let's keep these slices together. And now I'm going to cut this loaf of bread again, but I'm going to do it not like that. What am I doing? A line. I'm going to cut it sideways into 5ths. Why sideways? Because seriously, I am doing a terrible job here. Equal pieces sideways, maybe like that. And there. Try and make the pieces as equal as possible because it'll help the intuitive understanding. All right. So by cutting it this way, how many pieces of bread do I have now? Well, the whole loaf is cut into 1, 2, 3, 4, 5, 15. 15 pieces, and I have 10 of them. These two fractions are equivalent, meaning they represent the same quantity. Clearly, it's the same loaf of bread. I have the same quantity. I just cut it sort of differently. Now I'm going to take this other loaf of bread and cut it sideways in thirds, 3 equal pieces, this way. Now the pieces might not look the same, but I've cut this loaf of bread into 15 equal pieces again. How many do I have? I have 9 of them. So now these are comparable. These are comparable, and I can say this one, the left one, is greater than the right one, because I've changed these into equivalent fractions with the same denominator, which is much easier to compare. Now I can clearly say, well, if I cut a loaf of bread into 15 pieces, I would have 10 on the left, but I would have 9 on the right. So this one, the left one, is better, is greater. So 2/3 is greater than 3/5. So I'm still on my intuitive side because I'm using a diagram to write it into equivalent fractions with the same denominator. And it's really very simple. For the left one, it was thirds vertically. I'm using the other denominator and go horizontal. For this right fraction, I had 5 pieces vertically. I use the other side's denominator and go sideways. So this denominator is the product of the two denominators, 3 times 5, sorry, and this one is 5 times 3, if you will, but it's the same. It's the same. Now how did I get to 10? Well, the 2 columns that I had now each have 5 pieces. So if I have a fraction 2/3, it seems like I can multiply the top and the bottom by the same number, and I'll get an equivalent fraction. Same thing here. I took the top fraction and I said, well, the quantity doesn't change. I'm going to multiply the top by 3, the bottom by 3, and because I've done it on the same, I've done the same thing on both the numerator and the denominator, I get an equivalent fraction. So I've done that graphically, but it doesn't have to be graphically. I could have just chosen a number, and this number is still the denominator of the other fraction. This number is still the denominator of the other fraction, to make the two denominators the same. So let's do some exercises here. Simplify the following fractions as much as possible. So what does that mean? Well, if you now think of it backwards, that if you give me the fraction 10/15, I can factor these numbers and work backwards to simplify it to 2/3, and I can't do it anymore. When they have a common factor of 5, I can do that. Here, 9/15, they have a common factor of 3, and if I write it like this, I'm essentially quote unquote canceling the common factor. And people tend to cling to that very much. But it's really because I can rewrite a fraction like this, working backwards. It seems like I'm canceling these 3's, which is a handy way to remember it, but that's not really what we're doing. It's just a property of these diagrams, making vertical lines and horizontal lines. But because now we understand how we got here, we can apply the shortcut of quote unquote canceling common factors. This shortcut encourages no understanding whatsoever. You have to develop the intuitive understanding first before using the shortcuts or formulas. So what's the exercise number 14.4? Exercise 14.4, number 1. You know, I just looked at it. What was it? 2/18. 2/18. I can write as 1 times 2 over 9 times 2. Working backwards with the same concept, whether I draw rectangles or not, I have an equivalent fraction of 1/9. Number 2. Do I have more than that? Oops. No, this doesn't want to scroll at all. Wow, that's nice. Can't scroll for some reason. 4/16. 4/16. Well, that's 1 times 4 over 4 times 4. I can think of it like canceling a common factor, and I get the equivalent fraction 1/4. 2 3/6. When I simplify, I don't have to simplify the whole number portion, only the fraction. Whoopsie, I didn't do anything. 1 times 3, 2 times 3. So that'll be 2.5. Let me just do one on the side here. If we simplify, let's make it number 4. An improper fraction, let's say 18/12. Well, I can simplify. I can write this as what? What goes in there? 3. 6 times 3. 4 times 3. So that's 6/4. I can do that again and say, well, that is 3 times 2, 2 times 2. So that's 3/2. You can do it in steps. You don't have to see the factor to cancel. You can take out little factors that are common and systematically get it down to a simplified form. All right, I think that's good enough. Look at the book if you need to. Before moving on, all of these concepts have to be perfect.